let me, I guess, get started here by pointing at the agenda. So first order of business is the agenda. Then I'll talk a little bit about me and my background, and then we'll dive right in and start focusing on why languages are important. And there's a lot of good reasons why we should focus on language as something that we can use as a tool to improve the quality of our search results. So that at least will get us started. Then we'll talk about some of the different technologies we can actually apply to the problem to figure out what tools we have to influence how language is processed inside of Solr. And then, of course, we come to the configuring of Solr. There's many different options that we have, and so there's many different ways that we can go about this. So thinking about the different configuration options is very important. Working at a pharmaceuticals company, doing some very interesting work with sort of scientific data. That was my first exposure to real data, and it was very, very interesting. Also working with sort of building a Linux, molecular modeling cluster before Linux and cluster were words that one used in a sentence together. This was 12 years ago. On commodity hardware. So a lot of fun. Then I moved to BBN Technologies, which is a research company in the United States that does a lot of work on speech-to-text and machine translation. I worked there on building systems that did essentially 24-hour, 24/7 speech-to-text and machine translation, as well as an application that surrounded that, building an archive of 1 year of searchable content from news sources. And so sort of that gives you at least a little bit of an idea of where I came from and sort of how I started to approach these. A number of different types of distributed systems, but all of it comes back to search and getting access to information. So I think this should be pretty clear. Language is very important. It's the way that we all communicate. Just out of curiosity, maybe we could see a show of hands. How many people in the room have written an email in the last week in English, for example? Looks like almost everybody. How many of us here have written an email or a document in a language other than English in the last week? Still almost all of you. So here in Europe, of course, much more than perhaps in the United States, we see that people are multilingual. They're speaking in multiple languages and they're communicating in the way that the other party would like to hear the communication or receive the communication. So language is important. And a lot of different places, a lot of major companies and news sources recognize this. BBC publishes their news in so many different languages because it's important to consume content in your own language. Similarly, big companies like Salesforce.com lets you identify where you're coming from so that they know how to process your queries properly and how to find you the content that you're looking for. We see it all over the place. Microsoft Bing gives you these advanced tools to say, I only want to search these languages and tokenize or lemmatize my query in this way. And so it lets you have an impact on how your searches actually run. And so these, all these big companies and so many more, they agree that language really is important and it makes a difference. Now, some of the reasons that language is important, again, as I mentioned, content is being created and consumed by all of us here in many languages, not just one. And that means that a collection of documents, a collection of emails, no longer has just one language in it. And so if your search engine treats all content the same, it's not going to work as well as it could if you treated each language properly. And part of the reason of that is that each language is a little bit different. Some languages belong to the same language families, and so they have similar properties, but the words themselves are different, and how the words are actually formed are very different. And so understanding that, you can have a better way to sort of search the content. Starting out sort of thinking about why this is a hard problem, you can start with tokenization. Now, most European languages, it's pretty easy. You find white space, and that's where the word boundaries are, more or less. There's some other smarts you can put into place, and Solr has, the default tokenizer is actually pretty good at that. But some languages, Chinese, Japanese, Korean, Thai, and a few others, they write without spaces at all. So how do you tokenize those languages? How do you find the individual words to sort of put into the search engine to give you the results back that you're looking for? Similarly, other languages like German, Dutch, Danish, Swedish, Norwegian, these languages have compound words where they join two or more words together to form a new word. And in many cases, when you're searching, you're not going to write the whole compound word. You're going to be searching for just one of the compound components. And so we'll get into some examples of how this is a problem later. The other challenge, though, that's really prevalent in European languages is inflection. This is the way that words are changed as they're used in sentences. They represent things like tense. Are we talking current, present tense? Are we talking in the past? Are we talking in the future? Or are we talking about a masculine or a feminine object or something like that? And so all of these things have an impact on how words are written. A cute example that I found on Wikipedia on the page on inflection is the word gato, or gat, in Spanish. So here we have a cat. When the cat is a male cat, it's gato. As a female cat, gata. And so we start to look at how this type of inflection, visually we can see when you have multiple, there's plural. So now we have to change the word yet again. So here we have 4 or 5 versions of the same word just describing one object. Now, this is a cute example, but it's a relatively mundane example. So this is one of the easier cases in a language like Spanish. One of the harder cases, a word like pasaportar, has I think 4 different meanings and over 50 inflected forms. And so if you would imagine yourself trying to search for one of these words or search for passaportar, you want all of these words to come back as a hit, right? And so you have to be able to have these all match. But how do you do that without really killing your precision and increasing your recall? It's a hard problem. Just to give other examples, it's not just the explosion of potential inflected forms or surface forms. There's also ambiguity that exists as well. In English, an example is the word spoke. Sometimes spoke is being used as a noun, part of a wheel, which means the dictionary form is just the word spoke. On the other hand, when you're using it as a verb, it's actually, well, the word speak. And so what you want in your search engine index and at query time is the word speak. And so understanding that these words have different meanings at different times lets you start to get a grasp on some of the challenges that different languages pose. In English it occurs fairly frequently, but in French, Italian, Spanish, many of the European languages, it occurs much, much more often. So we can see here examples from French. In a language like German, like we see here, the challenge here is that compound word that I was describing before. Samstagmorgen means Saturday morning. And if I'm a user and I'm searching for something that happens on Saturdays, well, I'm going to type Saturday. And I would expect that documents that contain Samstagmorgen come back as part of my search results. And so if you're not pulling these words apart and decompounding them, you're not going to be able to find the results that your users are expecting. And that's really what it's all about, is making sure that the users are able to find the content that they're looking for. And as I mentioned, some languages, Chinese, Japanese, and Korean, don't have spaces at all. And so in the example here, it'd be very, very hard to figure out where exactly the word boundaries are in this stream of characters. That's one whole sentence right there, full of words, but where are the words? And how do you put those into your search engine index? So now that we understand a little bit about the challenges of languages, let's talk about the different types of approaches we have for handling these. To start off with, if you know the languages of the documents or the content that you're processing, that's great. Most people don't. And so really pat yourself on the back if you do know the language of the documents that you're working with, because it's really hard to get a grasp on that. And so there's language identification technology out there that will help. Then we have to think about the tokenization problem. For those Asian languages, how do we actually find the words, or what other approaches are there? Then we deal with the individual tokens. How do we find the appropriate form to put in the index? How do we go from spoke to speak? Sometimes, and other times keep it as spoke. And so there's a couple of different approaches you have to that area, and we'll dive in. And finally, when you get into higher level analytics, knowing what language you're dealing with is good, but knowing what language and what genre of the text you're dealing with is even better, because these different types of entity extraction modes of statistical entity extraction, machine learned models and things, they rely very much on the content and the type of context that they're operating with. So the more you know about your content, the better all of these things will do. Now, starting with language identification, I think offered in 3.5, there's going to be the language identifying update request processor, which I'll touch on again in a minute. But that's going to be good or at least it's going to be okay at finding the dominant language in a document. But that works for most use cases, but what happens if you have harder documents, something maybe like this, where you have several languages inside of a single document? Now, this is one that I just sort of made up, but very often we see this in email archives where you'll have a disclaimer from your company written in one language and the actual email is written in a different language so that the intended recipient can read it in a language they understand. And so we see this all over the place. So understanding your language is, of course, the first step. Next up is this notion of tokenization, finding the words in this stream of unbroken characters. Here we're looking at, how do these string of characters turn into tokens in the index? Now, out of the box, Solr provides something called the CJK analyzer. And what this basically is an n-gram approach. It's taking, in this case, it's a bigram approach. It's taking 2 tokens at a time, and it's sort of overlapping them by 1. So the first 2 characters are word number 1. Character number 2 and number 3 are word number 2. And so because we're sort of overlapping all of these, what we end up with in terms of search is perfect recall. You will never miss a document if you're doing n-gram analysis in one of these languages. The problem, of course, is the precision. You bring back so many results, how many of them are correct? And then what impact does this have on your relevancy? Where the algorithms inside of, for relevancy inside of Solr and Lucene are based on term frequency, inverse document frequency, and a number of related things. What happens when you're not operating on words? You have these sort of overlapping windows of characters. How does that impact your relevancy? I'm sure it's not good, but you have to test it and you have to see it to find out just how bad or how good it is for you. On the other hand, there's software that can do real sort of morphological analysis. It's a big word for saying segmentation or tokenization. And so this actually looks at the structure of how the sentence sort of fits together and finds the different possible theories for ways you could segment it, and then picks the most likely of those based on sort of training data or information it knows. And what that gives you, though, is it gives you real words. And those real words allow the rest of the system to work sort of as expected. Thinking on the token level for a minute, the notion of stemming versus lemmatization. So stemming, hopefully most of us here are familiar with stemming, but just in case, stemming is essentially a set of rules applied to a language that are designed to chop characters off the end of words. And in many cases, it works pretty well. It takes a word like speaking and turns it into a word like speak. And so in that way, it's able to handle some common endings and things like that and collapse multiple forms to the same representation. But there are 2 problems. It doesn't know about irregular verbs. It doesn't know about irregular anythings. And so it doesn't know about individual words. This means that a word like spoke, nothing happens when you put it into the stemmer. It just stays spoke. And that's not good if you were hoping to find speak. On the other hand, you have other problems. In the example here that's highlighted under stemming, you can see it took the word several, and for some reason it chopped the AL off the end, making the word sever. And that type of collision is very, very bad because it increases your sort of negative recall. It brings back documents you don't want. And so that hurts the user experience significantly. And honestly, it turns a lot of people off to stemming altogether. So many people just disable it after having tried it for a while. On the other hand, lemmatization, this is a more complex process that involves sort of language-specific dictionaries as well as things like statistical models, and the idea is to find the appropriate dictionary form of a word. So in this case, it takes the word spoken, it realizes this is a past tense verb, and so it's able to say then the dictionary form of spoken, when it's used as a past tense verb, is the word speak. And so it's also able to recognize several is a real word, and so we shouldn't be chopping things off of it. And so what you get is much better results in your index, and you're able to then find the results that you expected. So the notion of stemming versus lemmatization, in concept, their goal is the same, to increase your search recall. But stemming hurts your search precision while increasing recall. Lemmatization tries to balance increasing your recall without hurting your precision. So it's, these things are very hard to measure. If any of you have a measurement framework for measuring precision and recall of your search, I applaud you. It's very, very hard. But the more that you can test this and the more that you can understand how your users are doing, I think the better off you'll be. We have, I can show examples in many different languages here. Samstag morgen, again, here's that same example of Saturday morning, being able to say, okay, well, what happens when we apply the stemmer to this? And what happens when we apply a lemmatizer to it? We're able to find the compound components, and we're able to lemmatize them. And we're able to take these other words here and find the sort of appropriate dictionary forms. And this gives our users at the end of the day a greater chance of finding the content that they want if they're using one of these inflected words. And in many languages, almost all words are inflected. Other things that we're doing here as sort of part of this is you can also think of doing things like part of speech tagging. Behind the scenes, as part of that lemmatization process, part of speech tagging is taking place to help. It helps you figure out which possible dictionary form it is. It shows us the difference between spoke, the noun, and speak, the verb. So that's also helpful. You can do other things as well. Once you have this sort of part of speech tagging, you can start to extract noun phrases, sort of a basic attempt at getting concepts or entity extraction almost, although entity extraction is a bit different. And so you're getting a lot of different information out. So this just shows a couple of different sort of things you can do once you're starting to do this type of analysis. But going up to the higher level, beyond just search, well, maybe you want to do entity extraction. And entity extraction, as I mentioned, is very much language dependent. It depends on the language, it depends on sometimes on the type of content that you're processing. And so here we see an entity extractor running on an English news document. If I try to run this same entity extractor on a French news document, it's not going to work at all. Or if it is, it's going to be pretty bad in terms of accuracy. And so as you start to build on top of this, going even further beyond entity extraction to things like relationship extraction, the quality of each of the components that you're sort of depending on and relying on becomes more and more important. So having a strong base of understanding the language and processing each language properly becomes more and more important. I want to start to talk about how you would configure Solr to enable this type of multilingual search. Our goals here, of course, are we want language identification, and we want a language-aware tokenization, token level processing, that lemmatization or stemming, and then entity extraction perhaps. But some of the challenges that we're going to face almost immediately are what do we do if we have multiple languages in the same data set? And this is where things get really challenging. But before we go too deep, let's talk about the Solr tools that we have to actually configure these things with. Hopefully most of you are familiar with all of these. There was a good talk this morning about update request processors. I won't go into too much detail, but I'll define it a little bit in a moment just to make sure we're all on the same page. Then you have the sort of standard set of analyzers and tokenizers and token filters, and then you also have an option here of using Solr Cores. And I'll get into the different ways that you can start to use these different components to configure a multilingual search engine using Solr. This is a search engine that contains documents in more than one language. So starting with the update request processor. The update request processor is very, very powerful. It runs inside of Solr, and it runs before a document is analyzed. So it's, you get access to the document coming over the wire before any of the fields begin to be processed. And so this gets you full access to the document, and it lets you do a lot of interesting things. Now, when you're thinking about what type of analysis or analytics you could run in these, you sort of have to think about how your Solr system is architected. You have two options, essentially. You can run the analysis directly inside your update request processor. If it's a memory-intensive process like entity extraction, and if it's slow, maybe that's not the right answer for you. You could also call out to an external service. You can do something like WEMA or one of these other frameworks. I believe in the latest version of Solr, there is a WEMA connector as part of one of the example update request processors. So you could, in fact, call out and get entity extraction and get some of this other type of analytics run on your content before you even begin indexing the content, so that you can add that as additional metadata on the document. Because if you're running entity extraction, for example, you want to know what entities you found, and you want to index them as part of your document. And in Solr, it's a bit hard to come back later and add that information. You don't want to re-index documents just because you want to add a little more information, so you want to do this before the documents get into the index. And again, this really comes back to thinking about how you're indexing your content and how fast you need to index it, and sort of where you want the computation to run. On the other hand, analyzers and tokenizers, these are good for things like segmentation of Asian languages. You can get a tokenizer to do that type of segmentation. As well as the linguistics, that lemmatization that I described before, really processing the text sort of where it stands and indexing the results of that processing into Solr. And that's a great place and a great use for the analyzers and the tokenizers. And of course, we all know in the schema where these things all live, so I won't spend too much time there. The problem here, though, is that there's no access to the document object. So I can't run my language identifier as an analyzer or as a tokenizer, because once I do, what do I do with the language? almost always I'm going to want that language that I detected to be a new field on the document so I can filter on it, so I can allow users to see content from certain languages. But because the analyzers don't have access to the document object, they can't add new fields to the document while they're processing. So this isn't a good place for something like language identification. So for language identification, the update request processor really is the best place. It runs before the field level analysis takes place. You have an opportunity now in newer versions of Solr to actually try this out, this type of capability with the sort of basic language language identifier update request processor that's included. And you can start to see some of the docs on that on the wiki. Of course, you can also run this outside of Solr as a preprocessor. There's nothing wrong with that. Maybe you have a robust document processing pipeline ahead of time. And so that's just another thing to consider as you're looking at this. Maybe update request processors work for you. Maybe having an external pipeline of document processing would be more appropriate. But here we run into the challenge almost immediately. Once we detect the language of the document, what do we do with it? How do we use that language information to control our indexing? And how do we, how do we process the text and how do we store it in Solr? So there's a couple of different options in ways that we can approach this. Now, when you're trying to store more than one language in sort of one Solr setup, you can take the sort of simplest approach, and the one that I recommend first is setting up one field for each language. The default Solr schema today has text_en and text_general as sort of new fields, right? And that's sort of saluting the flag of saying that this is a very easy way to think about how you store different languages. Now, in terms of pros, it's very simple. It's very straightforward. Content lives in one Solr index, but it's in different fields. When you run a search, you search the fields you're interested in, maybe using Dismax to make the query language a bit easier. Then one of the real advantages of this approach is that it guarantees that the queries are processed in the same way as the index. So if I put English text in a field called text_English, and I query that field, my query will be sort of tokenized and lemmatized the same way that the index was. And so you're guaranteed that you have the same processing at query time and at index time. This is very, very important. You want to always make sure that the type of processing you do at index time is the same you do at query time. Unless you're sort of doing something a bit more advanced, you really want to make sure that they line and so that you're able to find what you're looking for. Now, the cons here, of course, if you're supporting a lot of languages, that's a lot of fields to define. And it could also be a lot of fields to search. And so as you start to scale up in terms of the amount of content and the amount of languages, it might actually become a performance problem. And so you want to really think hard about what's the right approach for you today and what's the approach you're going to wish you took, next year or the year after. And again, there are other approaches here as well. Some of this information, sort of on the next couple of slides here, I do have to reference one guy I have a lot of respect for, Trey Granger at Career Builder, gave a talk at the Lucene Revolution in San Francisco that included some of these same concepts in terms of how did they approach multilingual content, and I'll tell you which of the three options here they actually went with. So first option, again, one field for each language. Second option gets a lot more complicated. One Solr Core for each language. Now, the nice thing about this, you have a single field. The field could be called content, it could be called text, and it contains all of your text, all of your content in all of your languages. It's good because there's no sort of query time performance overhead. It's all one field, and different languages are stored in different cores. Now, that also helps you guarantee that the queries are processed the same way as the index. But there's a lot of complexity in managing these cores. You have to implement custom sharding based on the language, and you have to only implement custom sharding based on the language. If you already have a different sharding strategy, now you somehow have to integrate the language sharding as well as your existing sharding strategy, so it gets complicated. And, well, what happens if you have a document that has more than one language? How do you put part of a document in one Solr Core and part of a document in another? I don't know, you split the document, keep the IDs the same. It's hard, and it's a lot harder. And so thinking about this as an option, well, there's a lot more complexity here in terms of how you would manage this. But what it does really simplify is the query language. And so if you have a very, very complex query language, some of the customers and some of the folks I've worked with do patent search. They have Boolean expressions that go out to 50 or 60 different operations, maybe even more. And having them even try to consider adding multiple fields to search on top of these 50 or 60 Boolean sort of expressions, it gets to be daunting, and it gets to be a real performance problem, and so it's not practical. And so this approach, while it has some drawbacks in terms of initial configuration and complexity, it would allow you to have a sort of simple query language that references just a single field, and then the search is executed across many fields. So it just gives you that extra ability to, I don't know, to configure it to whatever your needs are, I guess. This one is a bit more complicated. I don't know of anybody doing this today, but I've heard of people doing it sort of as their initial approach. Method number 3 is the one that Trey at Career Builder actually went with, and he indexes all languages into a single field. Now, I think that this is probably the most complicated out of all of these, but again, it has all of the benefits too. The single field makes queries and indexing very straightforward. Nothing special required here, no sharding required. You can just do whatever you're already doing. And you have the same schema and the same core as more languages are added. So you're not constantly changing and updating your schemas across a whole set of servers. You just have sort of one schema, and you're just adding more and more language into it. Now, the cons, of course, it requires a very, very complicated tokenizer, an analyzer. And what basically happens is, well, you somehow have to pass in the language information, so somewhere you had it, and so you pass it in almost prepended is what Trey does. He prepends the language code, or language codes, and into the text, and then the analyzer wakes up and looks for that prepended language code or codes and actually starts processing in those languages, stacks the tokens, and puts them into the index. Now, it's a nice feature being able to do that. Again, it keeps some of the pros that we talked about, but it doesn't guarantee that the queries are going to be processed the same way as the index. And so you might be searching in English, but finding results in a language that you weren't expecting. It also has the potential for really throwing off the TF-IDF counts. If you have a lot of content in English and just a little bit of content in French, well, all of the French words are going to seem very important to the algorithm, and so they're all going to come back as relevant documents. And so what does that do to your relevancy? How fine-grained will that actually work for you? It remains to be seen. Career Builder seems to be happy with their approach. They like the way that they've done their indexing, and so I don't want to discount that, but I just want to say that there's a lot of challenges here in terms of how do we index this content and how do we make it searchable. So sort of, I guess just to summarize again, language really is important and it really does matter. And the ways in which you index content and you find the language and you sort of design your Solr schema and your Solr cores and your indexing strategy, and it's really what it is an indexing strategy, is all designed around increasing your recall without hurting your precision. The end result, of course, that we're all interested in here is getting better results for the end users. And I think Grant did a great job this morning in his keynote sort of referencing and drawing attention back to the fact that it's the users at the end of the day who are running the queries, who are hopefully getting us all paid. And so that's who we have to understand. And if you understand your users and you see that they're not finding what they're looking for, maybe language or taking advantage of the language information that's available, maybe that will help at one more step into giving them the results that they want, and that will allow your whole application to be successful. So, with that, here's my contact information. Ask me any questions you have now or afterwards. Hopefully this was informative.